welcome back to my channel. In today's video, we are going to deep dive into AWS Identity and Access Management, in short IAM. If you are new to AWS, you might be wondering what IAM is and why it is so crucial. Well, IAM is the central to controlling who can access your AWS resources and what they can do with them. The video will cover everything about users, group roles, and policies. We will also go to the hands-on demos where I will walk you through creating IAM user and setting the appropriate permissions. Plus, we will discuss security best practices to keep your AWS environment secure. Let's dive in. Now, what is IAM? Let's start by defining IAM. IAM stands for Identity and Access Management. It is a foundational security service in AWS that helps you to manage who can access your AWS resources, what action they can perform, and how they are allowed to interact with the system. You can think of IAM like a digital gatekeeper. It controls who get the keys to your cloud environment, what doors they can open, and what they are allowed to do inside. IAM handles two main aspects: authentication and authorization. Authentication means it confirming that users are who they claim to be, and authorization means granting them the appropriate permissions based on their identity. This layered control is crucial because it helps you to enforce principle of least privilege, a best practice where users only get the access they truly need and nothing more. IAM support a range of identities including individual users, groups of user roles for temporary access, and policies that define permissions in a fine-grained manner. Now let's explore why IAM is so important. In today's cloud-native world where workloads, services, and teams are constantly changing, IAM gives you a centralized, scalable, and secure way to manage the access. Whether you are a solo developer or a part of large enterprise, IAM helps to keep your AWS environment compliant, auditable, and safe from unauthorized access. Imagine you have developed your application on AWS and you store sensitive customer data in a S3 bucket. Without IAM, there is no control over who can access that data. Anyone with the right endpoint or credential might be able to view, change, or even delete your data. That's massive security threat. IAM acts as a protective shield. It allows you to grant precise access only to the people or services that truly need it and restrict everything else. This minimizes the chances of accidental exposures, malicious attack, or internal misuse. It also plays a huge role in safe collaboration. For example, your developers may only need access to your EC2 instances, while your finance team might require accessing to the billing dashboard. IAM makes this possible without overexposing your environment. Beyond access control, IAM is also key to compliance. It provides detailed logs of who access what and when, helping you to stay audit ready and accountable. In short, IAM is not just a feature, it's the foundation of AWS security. It enforces the principle of least privilege, allows for granular access control, and serves as your first line of defense in the cloud. Now that we understand its importance, let's move on to the core concept of IAM and how these controls are actually implemented. Core concepts of IAM. There are four core concepts that form the foundation of how IAM works: users, groups, roles, and policies. First one, users. Users are the individual identities. They can be real people like a DevOps engineer logging into the AWS console, or application that access AWS programmatically via access keys. Each user has a unique set of credentials and can be assigned permissions directly or through a group. Second one is a group. A group is a collection of IAM users. Think of it as shortcut. Instead of assigning permission to every user individually, you assign them to a group. For instance, you could have a developer group that has access to EC2 and Lambda functions, and a finance group that can view the billing data. Third one is the roles. Roles are a bit different. They don't have long-term credential. Instead, they provide temporary permissions that can be assumed by trusted entities, like a user from another AWS account, a Lambda function, or EC2 instance. For example, an EC2 instance with a role can automatically access an S3 bucket to store log files without hard coding access keys. Fourth one is the policies. Policies are the rules that define what actions are allowed or denied, on which resources and under what conditions. They are written in JSON and can be attached to users, group or roles. A policy might say allow read access to S3 bucket name project data but only from a specific IP address. Together, these elements let you to create a secure, flexible and scalable access management system in AWS. By understanding and combining users, groups, roles and policies, you can precisely control access to your AWS resources and enforce best practices like least privilege and separation of duties. So, users are the individual identities with unique credential. Groups are the collection of users for easier permission management. Roles are the temporary permission assigned to services or users. And policies are JSON document that define the permission. These are the four main concepts for IAM. Let's go through the steps of setting up IAM in the AWS console to manage access to your AWS resources securely. Follow my steps. First, you need to log into your AWS account. Go to the AWS website and click on sign in to the console. Enter your AWS account credential and then sign in. Once you are in the AWS management console, in search bar type IAM. Click on IAM. This takes you to the IAM dashboard where you can start managing users, roles, groups and policies. Next, you will create users who will access the AWS resources. Click on the users in the left sidebar of the dashboard. Click on the create user. Give name to the user, developer. Dev1 user. Provide access to your AWS management console. I want to create IAM user. Click on the custom password. Give custom password here. Uncheck this box. User must create a new password at the next sign in. It's recommended. You have to do it, but now I will not uh, click on this. Next. Click on the next. Currently, I am not assigning any policies to the users. Click on the create user. User created successfully. You need to download this CSV file of your user's credential, username. This is the console sign in ID. After creating your user, click on the user. Copy the username. I hope you remember the password. Click on the incognito window. Go to the AWS console. Sign in. Type your username. Type your password. And account ID. You can get account ID from here. Sign in. Now you are signing into your Dev1 user AWS console. Now we will see which services we can use, means which on which services we have permission. Click on the EC2 instance. Go to the dashboard. See API error, instance running. You are not authorized to perform this operation because we don't have given any permission related to EC2 or any other permissions to other services. Now I will see how to give permission to the user. Now come back to your root account. Click on the user, dev1 user, add permissions, attach policies directly, search EC2, click on the Amazon EC2 full access, click on the next. I will add another permission, add permission, search IAM. In add permission, attach policies directly, IAM. Click on the IAM read only access. Next, add permission. Click on the Amazon EC2 full access. These services are allowed in EC2 full access. Go to the policies. You can attach policies in the JSON format. Dev1 user. These two policies I have attached to the user. Now go to the Dev1 user account. Refresh. Now you are able to launch your EC2 instance. This is all because we have attached EC2 full access policies to Dev1 user. Now I have also attached IAM read only policies. Go to the IAM. Click on the user. See, we can see the Dev1 user here. Now I will add another user. Give name Dev2 user. Provide user access. Custom password. Auto generate password. Next. Click on the next. Create user. Access denied because we have given policies IAM read only access. We can see the user details, group details, role details, but can't edit or create any role user in this account. Now we will create a user group. Click on the user group, create group, give name admin, give administrator access, create user group, admin user created, one more create group, user test user group, give permission EC2 full access to the test user, create user group. Now we have two groups, admin and test user. Now go to the user, create one user, user admin, provide user access to the AWS management console. I want to create user, custom password, give password. User must create new password when sign in. Next. Now add this user in the user group admin. So policies attached to the admin group are attached to the admin test user. Next, see, we have two permissions. IAM change password, admin. This admin has administrator access. This is the JSON view. All resources are allowed. Go back to the user, create user, download CSV file. Return to the user list. Now I will create another group. Click on the user group, create group. Sorry, click on the user, create user, give name to the user Dave, provide user access. I want to create user, custom password, give password. User must create new password by checking this checkbox. IAM user change password policy is directly attached. Click on the next. I will add two user group to this user, admin and test user. Next. See, the permissions are administrator access, IAM user change password, and test user. Create user. Return to the user list. Click on the user tab. See, the permissions are admin access, Amazon EC2 full access, and IAM user change password. Because I have added two groups. Through groups, I have attached policy to the specific user. I hope you understand these steps. First create user, then add to the groups, then attach policies. And about role, I will explain in another video. Now, shared responsibility model. AWS operates on shared responsibility model. This means that AWS is responsible for security of the cloud, including the physical infrastructure, the network, and the underlying hardware. However, you are responsible for the security in the cloud. This includes managing user access to your AWS resources, setting up IAM users and permissions, and ensuring your applications are securely configured. IAM is a part of your responsibility. It is your job to manage who can access to your resources and what they can do with them. So it's important to understand how IAM work and set up your AWS account with security in mind. Now that we know how IAM works, let's go over some security best practices you should follow. First, enable MFA, multi-factor authentication. Always enable MFA on your root account and any high privileged users. MFA require a second factor like your phone to authenticate the user, making it much harder for attackers to gain access. I will suggest Google Administrator for MFA. Second one is the follow the principle of least privilege. Only grant users the permissions they need to perform their job, nothing more. If a user only need read-only access to S3, don't give them admin rights to EC2 or other services. Third one, rotate access key regularly. Access keys should be rotated regularly to prevent abuse. Old keys should be deactivated and deleted. Fourth one is use roles for the AWS services. Instead of embedding access keys in your application, use IAM roles for the services like EC2 and Lambda. This way, services can assume roles to access resources without hard coding keys. Fifth one, avoid using root users. The root user has full access to everything in your AWS account, so you should never use it for everyday tasks. Instead, create IAM user with the permission needed for specific tasks. Sixth one, implement strong password policies. Make sure to set a strong password policy for IAM user. This ensures that passwords are complex, difficult to guess, and regularly updated. Another one is enable CloudTrail logging. Monitor and audit IAM activities. Regularly review your IAM user permissions and policies. Ensure that the least privilege principle is still in the place and that are no unnecessary permission granted. Use permission boundaries. Permission boundaries define the maximum permission an IAM role can have. They are useful for managing permissions in large environment, ensuring that users don't escalate beyond their intended role. By following these best practices, you can ensure that your AWS environment stays secure, manageable, and compliant with the best security standard. Alright, let's quickly summarize what we have learned in today's video. First one, difference between root user and IAM user. We discussed the key distinction between the root user and IAM user, emphasizing that root user should only be used for account management, not for everyday tasks. Second one, why not to use root user for daily tasks? Using the root user regularly increases the risk of security breaches, so it is best to avoid it and for anything other than essential administrative tasks. Third one, how to create IAM user groups, roles and policies. We went through the steps of setting up IAM user groups and manage the permissions effectively. How IAM policies control the access. We demonstrate how IAM policies define what action a user or a service can perform on AWS resources, helping secure your environment. In our demo, we created an IAM user and assigned them read-only access to the IAM and full access to the EC2, showcasing how to implement these practices. Lastly, we emphasize the importance of enabling MFA, multi-factor authentication for all high privilege accounts to boost security. Remember, create user and give permission which is required to specific user. Don't give unnecessary permission to user and follow the least privilege principle for security. IAM is a key concept in AWS security and now you have solid understanding of it. With this knowledge, you are better equipped to manage users and the permissions securely in your AWS environment. Thanks for watching today's video. In our next video, we will diving into the database with IDS. We will learn how to launch MySQL or PostgreSQL databases, connect to them using tools like MySQL Workbench or the CLI and the cover backup, restore and snapshot concept which are key for maintaining your data integrity. We will also discuss best practices for working with the database in the cloud, ensuring your IDS instances are secure, optimized and scalable. If you found this video helpful, don't forget to like, subscribe and hit the notification bell to stay updated with our latest content. Feel free to leave your question or thoughts in the comment and I will see you in the next one. Thank you. And once again, thank you for your time and attention. See you soon.